Hello everyone. So today we'll be discussing about probability. So let's start from the very basic, that is the history of probability. So the history of probability can be traced back from the 17th century. So in the 17th century, gamblers who had great faith in superstitions, they are said to be the founders, that is they are said to be the founders of the theory of probability. Then the mathematicians, that is Galileo, Pascal, Cardinal and Fermat, introduced mathematics to solve the problem of uncertainty. Now, after the 17th century, in the 18th century and the 19th century, probability became a subject matter of interest. And after that, in the 20th century, a sampling theory, that is, we are still using the sampling theory, a famous sampling theory was developed by Carl Pearson and R.A. Fisher. That is the history of probability. And now, the present use of probability, that is, now we are in the 21st century, and today probability is used in various aspects of life. That is, it is used in almost all sciences, natural, social, physical, etc. And we have also developed two famous concepts from the theory of probability, that is the law of statistical regularity, the law of inertia of large numbers, and the sampling techniques that was developed by Carl Pearson and R.I. Fisher is used in many decision-making processes. So now we'll move to aim and definition of probability. So what is the purpose of probability, or why do we need to calculate probability? So the purpose of probability is to put a mathematical value to the uncertainty. Okay, and we can see a definition given by Ella Corner. Probability is an attitude of mind towards uncertain events. So we know that it is the uncertainty, that is, we are putting a mathematical value to the uncertainty. And another author, Laplace, have defined probability as the ratio of favorable events to the total number of equally likely events. And from that definition given by Laplace, we are formulating, or we are deriving a general equation to calculate probability, that is the total number of favorable cases divided by all possible cases. Okay, now today we'll be discussing the four approaches to probability. So the approaches to probability are basically divided into four. So that is classical, empirical, subjective and axiomatic. We'll look at each one of this in detail. The first approach is probability, that is classical probability. Classical probability is also known as priori probability. We are giving this name because we can determine the probability even before the event is happening. Okay, we look at it in detail, that is, we look at two examples to understand this approach of probability. So example 1, you can see, from a bag of 5 red, 8 black and 7 white balls, a ball is drawn. What is the probability that it is red? So we know that the formula given by Laplace, total number of favorable events divided by all possible events. So in this case, all possible events is, you can either get 5 red, 8 black or 7 white. So that is, total possible cases is 20, and the favorable case, that is, in this case we require a red ball. So the number of favorable cases is 5 and the total number of cases 20. So we get the answer as 5 by 20, which can be reduced to 1 by 4. So how is this a priori probability? Okay, I'll explain. That is, when we are given this question, that is, when we are given the information that there are 3 different colored balls, we can anticipate that is, even before we are picking up a ball from the bag, we'll know what its probability will be. So hence, this probability is known as priori probability. We look at one more example from the classical probability approach. So one more example is, what is the probability of getting a head on a single throw of unbiased coin? So we know that while tossing a coin, the only 2 possible outcomes are you either get a tail or a head. So we'll know the possibility even before happening of the event. That is, even before we toss the coin, we'll know the probabilities. So in this case, the favorable cases getting a head. So there is only one chance of getting a head out of the 2 possible chances. So in this case, probability is 1 divided by 2. Okay, now we'll move to the second approach of probability. Okay, the second approach of probability is relative theory of probability. Okay, relative theory, as the name suggests, this probability is calculated with relation to something else. That is, we are calculating the possibility with relation to something else. Another name of relative probability is posteriori probability, that is based on past experience. We'll be calculating this based on past experience. So we look at two examples to understand this concept in detail. So here you can see in example 1, the question is, if a machine produces 10,000 widgets one at a time and 1,000 of those widgets are faulty, what is the probability that machine is producing a faulty widget? So you can see that 1,000 widgets out of the 10,000, 1,000 will be faulty. That is, from the past data, we can understand that out of the total 10,000, 1,000 will be faulty. So with respect to the total, a certain amount will be faulty. So this can be considered as an example of relative probability approach. And how will we solve this problem? We'll use the formula relative frequency divided by total number of items. So in this case, the total is 10,000 widgets. So the denominator will be 10,000 and the numerator, that is the relative frequency, that is 1,000 with respect to 10,000. So the relative frequency will be 1,000. So we'll get the answer as 1,000 divided by 10,000, which is 0.1. Okay. Now we'll look at one more example of relative frequency to understand this approach. So you can see that in the second question or in the second example, your team has won 9 games from a total of 12 games played. Find the frequency of winning. So you can see that out of the 12 games played, they have won 9 games. That is, with respect to 12, they have won 9 games. So you can see that it is an example of relative probability. We are using the past data and we are relating it to the total number. So we can solve this problem with the formula relative frequency divided by total number of items. So the relative frequency, that is, they have won 9 games with respect to 12. So 9 divided by 12, which will give you 75%. Okay, so now we have discussed classical probability and relative probability. Now we'll move to the third one, that is subjective probability. Okay, subjective probability, as the name suggests, it is a kind of biased probability. That is, it differs from one person to another. From a point of view of one person, this probability is calculated from a point of view of one person. That is, probability of one person for the same event will be different for the other person. Okay, so this is also called personalistic theory of probability. We'll look at 2 examples to understand this concept in detail. So we'll move to example 1 under subjective probability. So you can see a picture on the slide, and here you can see the question, chance for the president of being elected again. So one person thinks that the chance of the president for being elected again is 50%, and another person thinks that the chance of president for being elected is 90%. So you can see it is absolutely different. That is about the same event. The event is the election of the president, and one person thinks the chance is 50%, and another person thinks the chance is 90%. So subjective probability is different from one person to another. It is entirely the perspective of a single person. Okay. So we look at one more example of subjective probability. You can see on the slide that John eats unhealthy food and does not exercise. So he thinks that he has a high chance of living over 100, but his wife thinks that he has a low chance of living over 100. So you can see that on the same event, that is, here the event is John living until 100. So John thinks that there is a high chance for him to live until 100, and his wife thinks that there is a low chance for him to live till 100. So you can see that probability is entirely personal and it differs from one person to another. Now we look at the last approach of probability, that is the axiomatic approach. So this approach revolves around 3 axioms given by a Russian mathematician. His name was Kolmogorov, and this is actually a mix of classical and empirical approach of probability. So we look at the 3 axioms given by him. The first one is that the probability will be always greater than or equal to 0, which means the value of probability will be a non-negative one and it will range between 0 and 1. The second one is that the total of sample space, that is all the probabilities in the sample space, will equal to 1. And the third one is that the union of two events will be equal to 1. Suppose in the sample space there are only two events, that is, we'll take the example of tossing a coin, and when a coin is tossed, we know that there are only two possible outcomes, that is, either you get a tail or you get a head. So the probability of getting a head is 1 by 2 and the probability of getting a tail is 1 by 2. So when you add the possible things in the sample space, that is the probability of getting a tail plus the probability of getting a head, which is 1 by 2 plus 1 by 2, you'll get 1. And the next one, that is the union. Probability of A union B is equal to probability of A plus B. So to understand this, we look at an example. So example 1, under axiomatic approach of probability, in the question they have given, in an election, there are 4 candidates. Let the 4 candidates be A, B, C and D. Based on the polling analysis, it is estimated that A has a 20% chance of winning the elections this time, while candidate B has a 40% chance of winning the election. What is the probability that candidate A or B will win the election? So here, the individual probabilities, that is, the probability of A to win the election is 20% and the probability of B to win the election is 40%. So using the third axiom given by Kolmogorov, we'll solve this problem. So the third axiom is probability of A union B. So the probability of A union B, that is, in this case, the probability that A and B will win the election. So the joint probability will be probability of A union B is equal to the sum of individual probabilities, which is probability of A plus probability of B. So probability of A, that is A winning the election, is 20% and probability of B, which is B winning the election, is 40%. So the joint probability will be 20% plus 40%, which will give you 60%. So we have solved this problem using the third axiom of Kolmogorov, that is probability of A union B is equal to probability of A plus probability of B. So the joint probability, that is the probability that A or B will win the election, is the sum of individual probabilities of A and B winning the election separately. Okay, so the answer of example 1 is 0.6. Now we'll move to one more example to understand axiomatic approach of probability. So you can see the question, what is the probability of getting 2 heads and 1 tail if an unbiased coin was tossed 3 times? So when a coin is tossed 3 times, we know we'll get 8 outputs, that is in the sample space there will be 8 outputs, and the required outcome, what is the required outcome? The required outcome is getting 2 heads and 1 tail. So out of the 8, we have to pick the items which has 2 heads and 1 tail. So we have found that there are 3 such results. So to get the probability of this, we'll be dividing favorable divided by total. So favorable outcomes are 3 and the total outcomes are 8. So here in example 2, we got the answer as 3 by 18. So today we've discussed 4 approaches to probability, that is classical approach, relative approach, subjective approach and axiomatic approach. Thank you.